With what we started with our review of different numerical types in Python, we're going to go over some of the basic building block items that Python provides, and these will be the stuff, the quirks, etc., that we're going to be building our programs from. So I'm going to start off with talking about strings. Before I move on, I'm just going to clear this. Okay, so first off, strings are immutable sequences of ASCII or Unicode characters. Now this immutable idea is important. A string once defined cannot be changed. In Python 2.7, like we're using, strings are ASCII code by default, but you can make a Unicode string by preceding its definition with the lowercase letter u, as in u, quote Brian. In Python 3, all strings are Unicode. This will be important because a lot of international textual data is not workable with ASCII, and so Unicode is needed, and sometimes that becomes problematic in Python 2. Okay, strings are specified using either a single quote or a double quote. It doesn't matter which one you use as long as you begin and end it with the same type string. And sometimes the choice of the string you're using is based on convenience. For example, if your string includes a single quote, you would want to define it with double quotes. This flexibility in using either single or double quotes, in my mind, is problematic because I end up programming inconsistently. And so my code is messy, harder to edit, because sometimes I'm using single quotes, sometimes I'm using double quotes. You can also use triple quotes to define strings. So either triple single quotes or triple double quotes, as in here. So this becomes very useful for strings that have quote symbols, for example, and is more general in terms of not caring about whether there's a line break, etc. in the string. So here's some definitions of strings. So making a variable Zeus is equal to Zeus. And in this case, in Python 2.7, this is an ASCII file, ASCII string. Here defining a variable Apollo, where I'm proceeding with the U, so this is going to be a Unicode string. Here I'm creating a Poseidon using triple single quotes. Now here I've created this string text1, and this is just kind of trying to demonstrate some problematic things you might run across. So I'm defining a triple string, triple quote start. I heard her say to the driver, and now I have within my string a quote. So quote, I wouldn't want to drive this bus myself. And you can see that when I try to do this, I'm getting a syntax error. So the end of line while scanning string literal. So what's happening here? So if we look carefully, so we're starting a string here with three quotes, and so Python is looking for the termination of a string with three quotes. So we come along here, here's a single quote, but we come here and it comes across and there's three strings. So it is at three quotes, so it is ending the string. And then there is a tag along of an extra double quote that Python doesn't know what to do with. So that's the source of the error. So what we'd want to do to break that up is put a space between the quote that is ending the quote within our string and the triple quotes that is terminating the string that we're defining. So if we redo that, now we get no error. Okay, this could also have been accomplished by using single quotes, triple single quotes to start it. And here we don't have any of the spacing problems. Okay. So depending on how much you're going to be using strings, it'll be useful to learn the definitions of the ASCII and Unicode string definitions. But let's just review ASCII code. So it has 128 characters. Each ASCII character corresponds to a unique number between 0 and 127. So the first 0 through 31 are control characters. 127 is the delete character. So to keep things simple, we're just going to worry about ASCII 2. So there are some useful functions in Python. First one is, the ORD function, which takes a string and returns the decimal value that corresponds to that string. And this is how strings are compared. And then there's the character function that takes as an argument an integer and returns the ASCII character corresponding to that integer value. So we can demonstrate that here. So what is the character that corresponds to the integer 89? I'm just going to split the cell here so I can do these one at a time. Okay, so that's the character uppercase Y. If I split the cell here, and then I want to know what the integer value is for the string capital A, that's 65. And like I said, this ordinal value, this 65 or this 89, is the basis of string comparison. And so if we want to ask the question, what's greater than or less than is capital A greater than or less than lowercase a? Well, if we look at the ordinal value, the ordinal value of lowercase a is 97. So the uppercase letter A is going to be less than the lowercase a. And so here we see that in this comparison, which turns out to be false. Okay, so a string is a collection, a sequence of characters. And this is the first example of a sequence that we're going to be talking about, and then we'll talk about lists next. We can access individual characters in a string with a square bracket syntax. So we're going to have a square bracket, the index of the character that we want to access from the string, and then a close bracket. It's important to remember the Python sequences start at 0. So the first element in a string is at the 0 position, not the 1 position. And then Python also provides a slicing notation that allows us to grab substrings. And the notation for that is the string name, the string variable, a square bracket, a start index, a stop index, and an optional increment. So start is inclusive, saying it will grab that index, but whereas stop is exclusive, that is, it will grab up to the position, but not including the index that we've specified. So here, if we come back up here, our text 2 is, I heard her say to the driver, I wouldn't want to drive this bus myself. So text 2.0 is the first character in that sequence, I. And here we're using slicing to grab the first 11 elements of the string, so that'd be 0 through 10, but excluding 11. So that is, I heard her. Okay, in slicing, start, stop, and increment all have default values. So the default start position is 0. The default stop position is the length of the string, and the default increment is 1. So here, we're not specifying a start, so that's going to be implicitly assumed to be 0. Here, we're not specifying an ending value, and so that is implicitly taken to be the end of the string. And here, and in both of these cases, the increment is taken to be 1 because that's not specified. In the last case, we are neither providing the start nor the end, so both the default values are used for those, but we're providing an increment value of 2. So let's see how this works out. So this is, I heard her for the first print statement say to the driver, I wouldn't want to drive this bus myself. And in this last case, we're taking every other character, which I don't know how we would pronounce that. Okay, so strings are objects. Like everything in Python is an object. And objects have attributes and methods. And you can access these attributes and methods using the dot notation. That is, I take my variable text2, and if I have the dot here, then I can hit a tab, and in IPython, it'll bring up all the different methods or attributes of this string. So let's see what is upper. We can get a help by the question mark. So this is a method, which is a kind of a function. You see, it's something that's going to be called with parentheses. Returns true if all case characters in S are uppercase and there is at least one character in S. Okay, so if we look at this, is upper going to be true or false? This will be false because there's plenty of lowercase letters in the string. Okay, here's another method. Is alphanumeric? Well, I don't know if it's an attribute or a method, so let's see what the help function says. Okay, this is a method, and it returns true if all the characters in S are alphanumeric. That is either an alphabet or a number. And in this case, if we evaluate this, let's see, oops, it's false. Well, why is it false? Well, because we have punctuations. We have quote symbols, and we have double quotes, single quotes, and we have a period. So the string is not just alphanumeric characters. Okay, in addition to the methods that are part of every string, there's also a string module. And the string module contains functions that duplicate a lot of the methods that are part of the strings, but also has additional attributes and functions that may be useful. So in general, what do we want to do with strings? Well, here's some of the list of things that I came up with. Oftentimes you want to change case. If you're comparing strings, maybe you don't want to concern yourself with whether there's uppercase or lowercase, and so we want to convert everything to uppercase or lowercase to simplify our comparisons. We might want to recognize punctuation that would help us in a narrative report, or split sentences, for example. We might want to check to see if a particular substring is in the string. So if we have a DNA sequence that's a string of characters, we might want to test whether a particular k-mer is in that DNA sequence. We might want to check to see if the string is a letter, a number, alphanumeric, punctuation. Might want to split a string into substrings. So a common thing that you would do in text processing would be to split off, say, a report into different, a radiology report, for example, like you'll do in the homework, into different component parts, the technique, the findings, the impression, etc. Oftentimes we'll want to concatenate multiple strings together or replicate them. So for all these different things that I listed, there's going to be methods that can be used in themselves or in combinations with others to achieve these. So first off, let's look at splitting a string. So each string comes with a method split. And this will take the string and split it into component parts and return it as a list. So here I've created a string which is 1, 2, 3, 4, 5. And let's look at what the help for the split says. Let me just split the cell here. So split returns a list of the words in the string S using the separator, which is an optional argument to the method, as the delimiter string. If the separator is not specified or is none, any white space string is a separator and empty strings are removed from the result. Okay, so let me put a cell above here, and let's see what happens if we just do a split. Well, here it returns a list, but it says list of a single string, which is just our original string, and that's because it's looking for white spaces as the default, because I did not provide a separator string. And so it's just returning the original string and putting it in a list. Now here I'm going to provide the separator of a comma. So now when we split this, now we have a list of each one of the individual numbers that were in our original string. Here's defining another string where there's spaces, and then when we split it, we'll have each of the words that were separated by white spaces as individual elements in the list. Okay, kind of the opposite of split is join, the inverse of it. And so it takes a list of strings and joins them together. And just kind of demonstrating that here. So I have an empty string. And so that whatever is here in this string, that is what is going to separate the strings that we have in the list that we're providing here. So here I have an empty list. Here I have a single space. Here I have a comma. Here I have a comma and a space. And here I just have a long string. And when we run this, you can see the different strings that get joined together. A string with nothing in between the elements, with a space between the elements, with a comma between the elements, with a comma and a space, and then a strange string between each of the elements. Okay, so as I mentioned before, strings are immutable. So there's no method or function that will change a string. They all return a new string based on what you're asking of the current string. So there's an upper. This will return a string that's with all the characters converted to uppercase. Similar with lowercase. Swap case just reverses them. There's a replace function. In this case, we'll take all lowercase a's and replace them with uppercase z's. Or here we're taking any white space and replacing it with an empty string. So let's see what happens here. Okay, just as described. There's a translate function to look into that you provide a list of a string of characters you want to change, and then a translation table. I'll let you look that up. The string method has a string that includes all the punctuations. There's a length that will return the length of a string. And if we take a string and we multiply it by an integer, it replicates the string. And so I'll let you explore that. Okay, so here are some of the things that we can check. We can check whether a character is alphanumeric, if it's an alphabet character, if it's a numeric, if it's a digit, if it's a white space. So for our string 10, it is alphanumeric. It's not alphabetical. It is a digit. It's not a space. Here's some of our special characters. So this represents a new line. This is a tab. And this is just the letter B. And we can see the results of that. Okay, an important string statement is the in statement. And so this is a Boolean condition. And what we're asking is string 1 in string 2, anywhere in string 2. And it will return either a true or a false. So here I've copied in a report. This is a radiology technique after a skateboarding accident of mine. And having defined the report, now I want to ask, is shoulder in the report? These different variations of shoulder. In this case, I'm going to take the report and I'm going to convert it all to uppercase before I do the comparison. And you see the different conditions. So there's no shoulder with a capital S. There is a lowercase shoulder. There's no all caps shoulder in the original report, but is when we convert it to uppercase. Okay, the find function or method finds the first occurrence of a string within the string. So here in the report, we're going to find where's the first location of edema. And then we're going to do things where we convert to lowercase first. Okay, so here, the first location of edema is at position 796. When I check for pituitary, pituitary is not in the report, so it returns the location -1. Okay, index has a similar kind of behavior. So it behaves just like find, but raises a value error instead of a -1 when the substring is not found. Okay, so there we got our position of the first position of the string shoulder. When we look for carotid, we get an error. Okay, I'm going to skip this. You can play around with that. So string formatting. Python has a variety of ways that you can insert values into a string. The old style is a C style, and here we have a string, the value of pi is, and then we have this formatting statement, and then we use the percent symbol to say which variables we want to insert into to replace that. And we can have multiple places where we're going to be inserting characters, and this means we're inserting a floating point. That means we're inserting a string. In this case, we're inserting an integer. Okay, since Python 2.6, there's been a new format method of a string that provides another way of inserting string values into strings, and that's demonstrated here. So lots more to learn about Python. If you look in the Learning Python, there's a description of the string formatting in Chapter 7, and we will be revisiting strings in detail when we do things like regular expressions.